In this video, let's go ahead and practice solving some proportion application problems dealing with measurement together. Alright, so for number one, we see that we have a recipe that's going to yield or make 12 tortillas, and it's going to call for 2 cups of flour in order to make that. The question is how much flour is needed to make 30 tortillas. Alright, so generally it's a good idea to just set up our units so we know what is going to be on top and what is going to be on bottom. And we know that 12 of these tortillas is going to call for 2 cups of flour. So we know we're going to have a 12:2 ratio. And the question is, well, what if we want to make 30 tortillas? Well, tortillas are on top, so we'll put 30 in the numerator of this ratio. And then let's go ahead and put X on bottom. X is going to represent how much flour we would need here. Now, there's several strategies you could use to go ahead and solve for this unknown amount of flour. But what I'm going to do first here is I'm just going to actually simplify this ratio on the left side and say that this is going to be the same thing or equivalent as a 6:1 ratio. And that's going to be equal to 30 to X. Then you can see here that you could actually just use the identity property and multiply by 5/5, or really just 1 here, and say that X is going to be equal to 5. And so you can really just say here that 5 cups of flour is going to be needed to make 30 tortillas. All right, let's check out number 2. In number 2, it says if it took 7.2 or 7 2/10 minutes to upload 8 digital photographs from your computer to a website, the question is how long would it take to upload 20 photographs at that same rate? So let's go ahead and set up an initial rate here. It's going to be a rate because we have different types of units. So we know that we're going to have 8 of these uploads per 7.2 or 7 2/10 minutes. So that's going to be our initial rate here. And the question is, what if we're trying to upload 20 photographs? Well, 20 is going to go on top here with the uploads. And our unknown here is going to be the amount of time. So X is going to represent that unknown amount of time here. Now, just like the last example, you could go ahead and use some different strategies. What I'm going to do here is I'm going to go ahead and divide actually both of these by 2, just so I can see I get actually a nice factor of 20 here. So this is definitely not how you have to do it, but I think this might be a little bit easier for me. So I'm going to write that we have a rate of 4 uploads per half of 72 is 36, so half of 7.2 is going to be 3.6, and that's going to be equal to this rate of 20 to X here. And the reason why I divided by 2 specifically is because I know 4 times 5 is 20, so I really just have to multiply 3 6/10 by 5, and that will get us what X is going to be here. Now I know 36 times 5 is 180, so 3 6/10 times 5 must be equal to 18. And so in conclusion, we can say here that it would take 18 minutes to upload 20 photos at that same rate. All right, let's check out a third example here. An exhibit at Tobu World Square in Japan includes a scale model of the Empire State Building. The model is built using a scale of 1 to 25 measured in meters. The height of the actual Empire State Building is 443 2/10 meters tall. What is the height of this model? All right, so I'm going to set up these units as the model is going to be on top and the actual measurement is going to be on bottom. We are told it has a ratio of 1 to 25. That's the scale here. So I'm going to go ahead and set up that first ratio for 25 meters in real life. We have 1 meters measured in the model here. So we have a 1 to 25 ratio. Now, as for the other side of this proportion, we know the actual measurement of the Empire State Building is 443 2/10 meters, and we don't know the height of the model, so we're going to use X to represent that. All right, I can't think of a great way to go ahead and solve this one besides maybe using cross products here, just because this 443 2/10 is not the nicest number. So I'm going to actually go ahead to just write the cross products, and if we go ahead and multiply 25 times X, that's going to be 25X. And if we go ahead and multiply 443 2/10 by 1, we can just use the identity property and write 443 2/10. Now if we just go ahead and divide both sides by 25, we're going to be able to go ahead and get the height of this model. So on the left side, we're going to get 1X, or just X equals. All right, so setting up this division here, we're going to see how many times 25 is going to fit into this 443 2/10. We know the decimal is going to go right up here. 25 doesn't go into 4, but it goes into 44 once. 1 times 25 is 25. Let's see, we're off by, it looks like 19. That's going to be a 9, that's a 1. We'll bring down this 3 here. 25 times 7, 8 would be 200, so that's too much. It's going to be 175. Let's see, 13 minus 5 is 8. 8 minus 7 is 1. We'll go ahead and bring down this 2 now. Let's see, I think 25 times 7, we said it was 175. I don't think we can get any closer. So that's going to be 175 again. Let's see, the remainder here, we're off by 7. All right, so when you get to this point here and we're dealing with decimals, just go ahead and add zeros in the dividend and bring it down. It doesn't change the problem at all. and keep on going. So 25 will go into 70 just 2 times. It's almost 3, but just 2. 2 times 25 is 50. And see, we're off here by 20. Okay, so let's go ahead and do this maybe one more time here. So add another 0 and bring it down. And that's now 200. So this 25 is going to fit into that exactly 8 times. 8 times 25 is 200. So finally we can see that we have no more remainders. So we know that this height is going to be 17 and 728 thousandths meters tall. That'll be the height of the Empire State Building model that is located in Japan. All right, let's go ahead and try number 4. Number 4, Mr. Lee lives in Philadelphia and commutes 45 2/10 miles to Princeton each day. On a map, the scale is 1 to 9, where 1 centimeter on the map represents 9 miles in real life. To the nearest thousandths, determine the distance between Philadelphia and Princeton on the map. All right, so we have units on the map and then we have units in real life. We're told that the scale is going to be 1 to 9, so let's go ahead and put that ratio down of 1 to 9. And 1 is going to be on the map, which is going to be 1 centimeter. 9 is 9 miles in real life. And where's that 45 2/10 going to go? Well, that's in real life. That's 45 2/10 is going to go on the bottom with the miles. And we want to know how far this is on the map here. Okay, so let's see. I don't think 9 will go into this 45 really nicely. There's no real simplifying we can really do here. We could multiply both sides by 45.2, but then I still think we're going to have a couple operations here that we're going to have to do. So in this case, I'm just going to use cross products. So 9 times x is just going to be 9x. That's not bad. And then 45 2/10 times 1 is going to be 45 2/10. That's not bad either. So that you can do pretty quickly. And then we can just go ahead and use the division property of equality and find out that 1x or x is equal to, and we just have to do a little quick division here. All right, so basically we're just going to figure out how many times 9 is going to fit into 45 2/10. It says round to the nearest thousandths place, so maybe it's not going to go in very nicely here, but that's okay. Let's see, 9 times 5 we know is 45, so it's 5 point something, right? And we have a remainder of 0, and we'll bring down this 2 here. So how many 9s will fit into 2? We can't fit it a whole number of times, so we have to put a 0 up top here. 0 times 9 is going to be 0. We're still left with 2. We can go ahead and bring down another 0 inside of this dividend. And 9 goes into 22 times. We're now at the hundredths place. So that's going to be 18. We have a remainder of 2. Let's go ahead and add another 0, bring it down here. This is 20 again, so I think it's going to just be a 2. Notice how this is 18, so actually this is just going to keep repeating, right? So we know the next number here is actually going to be another 2, and it's actually going to be repeating. So if we're being asked to round to the thousandths place here, the thousandths place is located right at this 2. So the 2 after it's going to just say to stay the same. It's going to say round down. So to the nearest thousandths place, we can say this would be 5.022. That's to the thousandths place here. And so we can go ahead and conclude that 9 miles in real life is going to be about 5.022 or 5 22 thousandths centimeters on the map. All right, let's check out number 5 through 8. These ones are going to be a little bit different. In these ones, we're going to have some units that need to be converted, so please be careful when you are looking at those units. If Mr. Lee prefers his coffee to have a ratio of 1 to 17, this is coffee grounds to water. How many kilograms of water does Mr. Lee need if he uses 70 grams of coffee? So I'm going to place coffee on top and water on bottom, but feel free to flip it if you'd like to. Just keep your units consistent. And I'm going to write this ratio of 1 to 17 here. Now, we were told that it says how many kilograms of water does Mr. Lee need if he uses 70 grams of coffee. So I guess the question is we should go ahead and figure out if it's 70 grams of coffee, let's go ahead and put that maybe on top. But keep in mind that this is currently in grams and we're looking for kilograms of water. All right, so let's go ahead and just see if we can figure out the amount of water we need first in grams, and then we'll convert to kilograms after. All right, I think for this one, I'm not going to use cross products. I think I'm just going to say use the identity property and just multiply top and bottom by 70, just because 1 times 70 is 70, so that's not too bad at all. So if we go ahead and take this 17 times 70, we can figure out how much water we need, at least in grams, right? So let's go ahead and multiply this out. This is going to be 0, this is 0, this is 49, carry the 4, and this would be 11. So we're looking at how many grams of water here. We're looking at, I think, 1,190 grams of water, if that means we have 70 grams of coffee. So we just found out that 17 times 70 is this 1,190, but again, this is going to be grams of water. So this is how many grams we have of water, but we're supposed to, if you remember reading the directions, that we have to use dimensional analysis and the identity property to show that we can convert this into kilograms. So we have units to convert here. So for dimensional analysis, that's where we're going to multiply by some equivalent ratios to help us convert units. So we have this much water. This is measured in grams. If you want to write it as a fraction, just write it over 1. But then how do you show we're using dimensional analysis and the identity property? Well, you want to think, what's the conversion here to get to kilograms? Well, we hopefully know an equivalent ratio here, and if not, you can look it up, that 1,000 grams is the same thing as 1 kilogram, right? So if you go ahead and see here, this right here is really just the same thing as 1. All right, so keep in mind that because these are equivalent values here, then we're essentially using the identity property, so we're not changing the value of anything here. Now, of course, really nicely here, you can see when you use dimensional analysis, the grams are going to cancel out here, and we're just going to be left with kilograms. So if you go ahead and just multiply the numerators together, this is just going to be 1,190 kilograms. And on the bottom here, we're going to see we have 1 times 1,000, which is just going to be 1,000. Now, when you divide any number by 1,000, you can just move the decimal over 3 spaces to the left. That makes it 1,000 times smaller. So it's going to be 1.190 or 1.19 kilograms. And so if Mr. Lee is going to be using 70 grams of coffee, in kilograms, he's going to want 1 1900 kilograms of water. So then we just went ahead and wrote that amount of water over 1 as a fraction. We multiplied it by essentially 1 using the identity property, but this is also using dimensional analysis because we're cross-canceling units here. And we're going to be left with kilograms. And you can just see here that we just have to do a quick little bit of division at the end here to get this 1 1900 kilograms. Another way you could have gone about this is if you wanted to convert the 70 grams of coffee in the beginning to kilograms, you could have done the problem in kilograms from the beginning, but either way, you're gonna have to convert at some point. Totally your choice when you want to do it. All right, let's try number 6. For number 6, the driving distance between New York City and Los Angeles is about 2,775 miles. If it takes about 40 hours to drive from New York City to Los Angeles, the question is how many kilometers per day would that be equivalent to? All right, so I'm going to set up a ratio, or a rate rather here, of distance to time. We know that it's going to be 2,775 miles, and that's going to be for 40 hours. And because we have so many different units going on here, I'm actually going to label that this is miles and this is going to be hours, just because it looks like we actually have to convert this into kilometers and days. All right, so I'm going to go ahead and just start by taking this amount of miles, 2,775. This is miles, and as a fraction, I'm just going to write it over 1. And let's go ahead, if we want to turn this into kilometers, we need to know the conversion. And so 1 mile is going to be, I'm going to put 1 mile on bottom because we want the units to cross cancel, is going to be about 1.609 kilometers. I think if you go to the thousands place, that's perfectly fine. Again, this is using the identity property and dimensional analysis just because this is essentially equal to 1. You can see that the miles here are going to cross cancel, right? So if you go ahead and multiply this 2775 times 1.609, you can go ahead and use a calculator for that and find out that this is going to be 4,464. And I'll write all 3 digits here, 975 thousandths. This is going to be kilometers over 1, or this is just going to be what it is in kilometers. Now, what about the time? Well, we have 40 hours here, so I'm going to write 40 hours. I'm going to put that over 1 here as a fraction, and we need to convert this to days. So what are we going to use here? Well, we know that there's going to be 24 hours, and that's going to be in 1 day. So I'm going to go ahead and just put 1 day. That's fine here. Again, this is an equivalent ratio because these are the same value. So we're using dimensional analysis to cross-cancel these hours here, but 1 day to 24 hours is a 1-to-1 ratio. It's the same value, so it's just equal to 1. That's using the identity property here. So if we go ahead and just multiply here, we have 40 times 1 day, so that's going to be 40 days. And in the denominator, we really just have to divide this by 24. And so we can actually go ahead and take this 40 and divide it by 24. Top and bottom, you can divide both by, I think, 8 here, right? So that would be 5 over 3. So I think this is going to be 1 2/3 days. And so if we're going ahead and writing an equivalent proportion here, we can also say that in kilometers per day, we know this is going to be 1 2/3 days. But how far can we go? It's going to be 4,464. Maybe we can just say 0.98 kilometers. That would be the amount of distance in 1 2/3 days. Now the question does say to find this out as the number of kilometers per day, so that's per 1 day. So let's go ahead and rewrite our rate that we currently have. We have this 4,464.98 kilometers. That's per how many days? Well, that's per 1 2/3 days. So what if we want to find out just per 1 day? Well, I think we're going to have to divide here by 1 2/3. That would be per 1 day. And we could take this and divide by 1 2/3 as well. So if we go ahead and do that, we will end up getting just a 1 day on the bottom, just because anything divided by itself is going to be 1. And then on the top here, you can just divide the decimal by the decimal version. You could say 1 2/3 is about 1.67 or 1.667, or you can use the fraction as well. So go ahead and use a calculator and you should get approximately 2,678.45 kilometers. And so if you're going to cover that total distance of miles in 40 hours, that's going to be the same thing as saying that approximately the same rate in kilometers per day would be 2,678 and 45 hundredths. And of course, this would be if we didn't take any breaks at all and just kept driving nonstop. All right, let's check out number 7. In number 7, it says that if 4 cups of sugar are needed to bake 180 cookies, the question is how many pints of sugar are needed to make 70 cookies? All right, so we can set up a ratio of sugar to cookies here. We know that we're going to need 4 of these cups. I'm just going to write the units here to be extra clear here. 4 cups of sugar are going to be making 180 cookies. This one's a little bit more clear, so I'm just going to leave that as 180. The question is asking about how many pints of sugar are needed to make 70 cookies here. So let's go ahead and do some unit conversions first here. I'm going to go ahead and take this 4 cups of sugar. Let's write 4 cups as a fraction, so 4 cups to 1. And let's go ahead and convert this into pints so that everything is in the correct units that we need. Now, there are 2 cups in every single pint, so I'm going to put the 2 cups on bottom, and I'm going to put 1 pint on top. So I'm just going to use PT for pint here. All right, so again, 1 pint is the same thing as 2 cups, so this is a 1-to-1 ratio here. So this is using the identity property, and as well as you can see here that we're using dimensional analysis, we can cross-cancel these cups here, and also we can actually cross-cancel the 2 and the 4 to make it 2 and 1. So if we have 4 cups here, we're going to see that this is going to be equivalent to what? This is going to be equivalent to the same thing as 2 pints, right? So we can also say this would be 2 pints of sugar would be needed to make 180 cookies. That's essentially what we just found out, and that is a true proportion that would represent this so far. All right, so we know that we need 2 pints of sugar to make 180 cookies. The question that was asking is, what if you want to make 70 cookies? So let's go ahead and set this up and say, let's go to put 70 over here for the number of cookies, and so we don't know how many pints of sugar we're going to need here. So up to you what you want to do for this one. I noticed that I could actually divide this ratio on the left by 2 and 2 just to simplify this a bit. I'm just going to go ahead and continue this maybe right over here. So this is the same thing as saying 1 pint of sugar is to 90 cookies. And that's going to say, what if we want to find X number of pints of sugar for 70 cookies? Now, it doesn't go in really nicely here, so I'm just go ahead and use cross products. So 90 times X is going to be 90X. 1 times 70 is just going to be 70. And if you go ahead and divide both sides using the division property of equality here, we can see that X here would be equal to, well, 70 over 90 is just 7/9. So we would just need 7/9 here of a pint. And so we can go ahead and conclude here that we need exactly 7/9 of a pint of sugar to make exactly 70 cookies. All right, let's try one more example together. In number 8, if a grizzly bear can run 30 miles in 1 hour, the question is how many feet can the grizzly bear run in 15 seconds? All right, so let's set up a rate here of distance and time. So we know that this grizzly bear can go 30 miles, and that's going to be in 1 hour. Now the question is asking though specifically about feet, and it's asking about seconds. So we have a couple different type of units that we're going to have to convert here. So let's see. Let's start with the 30 miles and let's go to feet. So 30 miles is really 30 miles over 1. Let's go ahead and see. We want to convert this into feet, so we have to know how many miles are in a feet or how many feet are in a mile. So I know here that 1 mile is the same thing as 5,280 feet. So this right here would be a conversion. So if we go ahead and multiply here, notice how the miles are going to cross cancel. If you go ahead and do that, if you go ahead and take a calculator and multiply 30 times 5,280, we're going to go ahead and get 158,400. And that's going to be just measured in feet. Now, notice how I kind of skipped a step. It's going to be over 1, so I didn't write that just because I saw there's going to be a 1 on the bottom. So we know the 30 miles measured in feet right now. Let's go ahead and convert the hours into seconds. So we know we have 1 hour. 1 hour as a fraction is going to be 1 hour over 1. We know that there's going to be 60 minutes in an hour, but we also hopefully know that there's 60 seconds in a minute. So 60 times 60 is going to be 3,600. So 1 hour is going to be equivalent to 3,600 seconds. And you could instead multiply by 60 over 1 and 60 over 1 if you want to. But this right here would be us using our dimensional analysis and our identity property here. So you can see here that we just have 1 times 3,600. So really this is just going to be 3,600 seconds. All right, so we had our original rate over here, and let's go ahead and set it equal to another rate so that we can write our proportion. So it looks like we know that this is going to be equivalent to 158,400, and I'm going to write the units so everything's very clear. That's going to be feet per 3,600 seconds. So we just formed our proportion here. Now I'm going to go ahead and rewrite this over here and just simplify it a bit here. So I'm going to go ahead and write this as 1,584 feet per 36 seconds. And I know you can simplify this a little bit more, but I'm not going to do that right now. And we're supposed to figure this out for 15 seconds. So 15 seconds, that's going to be on the bottom. And we're going to figure out how far this grizzly bear can go in 15 seconds. So up to you if you want to try to simplify the left side a little bit more, or if you want to use a calculator and just go straight into cross products for here, that's okay. These numbers are pretty big here. So 36 times x is going to be 36x. And on the other side here, if we have this 1,584, and we go ahead and multiply that by 15, we're going to see that that's going to be equal to 23,760. And we can go ahead and use the division property of equality here and divide both sides by 36. And we're going to see that 1x, or just x, is going to be equal to 660. All right, so in conclusion, we can say that we know that the grizzly bear then can, and so putting this all together, we essentially just found out that this grizzly bear, keeping the same rate, could run 660 feet in 15 seconds. All right, so there you have 8 different practice problems applying our understanding of equivalent rates and ratios, as well as writing proportions. The first 4 problems, we didn't have to convert any units, which is kind of nice. And in the second 4 problems, we had to think about the units and completing some dimensional analysis, as well to go ahead and make sure we were in the correct units to solve the questions correctly. If you found the video helpful in understanding how to deal with some of these more complex problems a little bit better, feel free to give the video a thumbs up and share the video with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.